We shall be discussing the laws of indices. Okay, briefly, I will just be explaining the basic laws of indices, because if you understand these laws, there's no problem at all in indices. You will not be able to tackle. All right. So if please, wherever you are now, I want you to be serious with this class. Get your notes. I always tell you to get your notes, get a pen, sit down and jot down, listen attentively. Probably indices has been a major challenge to you, and in mathematics, you cannot be good in mathematics generally if you don't know indices. Indices is one of the foundational topics in mathematics. All right, so please settle down. In these few minutes, let us use it to discuss the basic laws of indices. Watch this video carefully, pay attention, so that you would have enough questions. The proof that you listen is that you have questions to ask, because you will not always understand everything. That is just the truth. Okay, you will not always understand everything, but the proof that you listen attentively is that you have questions. So at the end of this class, I want to see many of you guys asking me questions. Sir, what about this? What about this? How do we get this? How do we get that? Why is it not like this? Why is it like this? So questions like that, I am expecting them. Okay, so laws of indices. Number one law of indices I want you to take note of is the multiplication law of indices. It's very simple. It says if you have x raised to power b times x raised to power a, if you have two bases like this, the same, please, they must be the same. All right, they must be the same. If they are not the same, you cannot apply this law, this rule it will not be applicable. They must be the same. X. So what is the law saying? Since they are the same, pick one and add the powers a and b. These are the powers a and b. Please take note, they must be the same. Not that you have something like x times y a b, you now say multiplication law of indices, that if you have two bases multiplying each other, you pick one of the bases. Please, I said they must be the same. This one, they are not the same. It means you cannot apply multiplication law here. All right, multiplication law here is totally useless here. So it's only applicable when you have two bases that are the same. Take note, they must be the same. So if you have, it means if you have 5 raised to power 3 times 5 raised to power 2, apply multiplication law in entails that you pick one of the bases, they are the same, add the powers 3 plus 2, which will give you 5 raised to power what? 5, which is equal to 5 raised to power 5 is what? Whatever is your answer, put it there, put it at the comment section. Okay, so the next rule you need to take note of is similar to the multiplication rule. The rule is just a little difference between them. All right, it is the division rule. So you have x raised to power b divided by s raised to power a. This time, the only difference between this rule and the former one is that this is what is differentiating them. That one was multiplication. This one is what? Division. So it's still the same principle. They are the same. Pick one of the base. This time you are subtracting the powers. A minus b, that is all. Okay, take note, they must be the same. XX or YY or BB, they must be the same. Another rule you need to take note of is this, that if you have something like this, s raised to power n all raised to the power of b, it is the same as using this, the power outside of the bracket, to multiply the power inside the bracket. So this is the same as s raised to power n times b, which is equal to s raised to power nb. Do you understand now? The same. Also, let's take, for instance, an example. You have 5 raised to power 2, all in brackets, raised to power of 3. This is the same as what? 5 raised to power 2 times 3. I'm using the power inside the bracket to multiply the power outside of the bracket. So it gives me what? 5 raised to power 2 times 3. That gives me 6. All right. So that is that for that rule. That is rule number 3. Now, rule number 4. Take note of this rule. This one is kind of similar to the first one, but they are not the same. Now, if you have something like xy raised to the power of, let me say, a. Now, you're having two of these variables inside of the bracket raised to a common power. What do? It is to share this power among them. In other words, this is the same as s raised to power. This a will eat from this power. Y will also take the power. Okay? They have it in common. It means if you have something like this, xy, all this power. I mean, if you have x times y, this power a, and this one is also a, you can also, since they are the same multiplication, you can also pick one of the power, that is xy. You pick one of the power, open a bracket and put it outside, telling you that the both of them, they have something in common, which is that base. Okay, please look at mistake most students usually make in JAM. They make this mistake like this. They tend to confuse this rule like this. If you have plus y raised to power a, please, this one is not the same. You see this one, it is not the same as s raised to power a plus y raised to power a. If you do this, you are wrong. This and this are not the same. Please because it is plus. But assuming you have it as multiplication, x times y, this one can benefit from here, x square a times what, y square a. Please take note of it. I beg you. If you have plus or minus here, it's not the same as splitting this among them. You understand what I'm saying here? It's not the same. It must be multiplication before this can take this, and also this y can take from this. The same thing if it is division, x over y, and they are all having a common power. You can, each of them can take from the power x square a over y square a. So this is true for both division and what, multiplication, but it's not true for subtraction and addition. That is, if you have something like, sorry, let me clean this. If you have something like x plus y all raised power 2, this is not the same as x square 2 plus y square 2. Please, it's not the same. It's not the same. It's not the same. I beg you, don't make that mistake. So another rule is, I would love to explain, is the negative index rule. That is, if you have something like x squared minus a, please, this is the same as, you see this minus, change it as 1 over, then this x becomes the denominator, then the a, you put it here. Take note of it. This is the same as this. So it means if I have something like 2 raised power minus 3, it is the same as, change this minus to 1 over, this 2 becomes 2 raised power 3. This is what, 1 over 2 raised power 3 is what, 8. All right. So if you understand that rule, I want you to solve this one now and drop the answer at the comment section. If you have 3 raised to the power of minus 5, please solve it and put the answer at the comment section. Solve it and put the answer at the comment section. Meanwhile, let us continue with our class. Another rule I want you to know is, if you have something like s squared a over b, all right, this is the same as, you bring this one will be here, this will be inside, and this a will still remain as the power of x. So if you have this, you can bring it to there, and if you have this, you can take it to be this, according to the laws of indices. Please, this is fraction index law of indices. We bring this one here. So if I have something like, let's say 8 raised to the power of, or 4 raised to the power of 1 over 2, this becomes what, square root, this 2 square root, but there's no need to put 2 here, because this one also, it already means square root of 4, power of what, 1, power of 1. This is equal to square root of 4 is power 1 is still 4. So square root of 4 is what, 2. Please take note of these rules. Take note of this rule. Solve this one and put the answer at the comment section. If you have something like 16 raised to the power of 1 over 2, please solve it and put the answer at the comment section. Okay, negative index law. The same thing if you have something like let's say 9 raised to the power of 3 over 2. All right, this becomes what, according to the fraction index law. What are we going to do here? We bring this 9 will be inside, this 2 will be here, and then 3 will be here. Okay, so this is the same as, remember, this is the same as 9 squared 3 means 9 times 9 times 9. All right, 9 squared 3 is the same as what, 9 times 9 times 9. And you have this covering everything. I can share it among them. It becomes square root of 9 times square root of 9 times square root of what, 9. Square root of 9 here is 3 times square root of 9 here is 3. Square root of 9 here is 3. If you multiply it, it gives you 27. Yes, it gives you 27. Thank you very much. Okay. Another rule we'll talk about is the zero law of indices. Anything raised by 0 is 1. That is what the rule is talking about. So if you have x raised by 0, it is equals to 1. Okay. And the xy raised by 0, everything is equals to what? 1. Please take note, this one is different from this. So this one is not equals to 1. The difference between this and this is that everything here is raised to the power of 0. While in this place, you only have y raised to the power of 0. X It's not raised to the power of 0. So it is only y here that is equals to 1. So you have this to be x times 1 equals to what? X times 1 is what? X. So take note, this and this are not the same, I beg you. I want to believe you're absorbing those laws we have been explaining. Now look at